processes and observations program is where we're looking to conduct field campaigns so that people go and take some measurements, improve understanding of how something in the world is working. Clouds and aerosols is one, the sea ice is another. There'll be other places where we have blended programs between process and observations and Earth system modelling, where we're looking to do a better job of making use of the available information that's already out there from process and observations to better constrain the climate model that we're using in this part of the world, in the southern half of the southern hemisphere. So in order to develop models, you need to have the model reflecting the processes that we observe in the real world. So, for instance, when wind hits a mountain range, it sets up waves in the atmosphere that go up that we call gravity waves, and those can have an effect on the flow at higher altitudes. So what we need to do is build the physics of the model in such a way that it captures those effects. So what you're trying to do is have the equations in the model reflecting reality. So imagine a little term in the equation where you've just got something, some variable, could be anything, equals I don't know, ax plus b. So you might have a physical variable that's y, and you might have a physical variable that's x, and what you need to observe in the real world are the a and the b. So you need to you may have quite a lot of confidence in the functional form, but you need to go and observe the things that tell you about the a and the b. So that's basically what the processes and observations program is doing, is giving us a better handle on the physical constraints, the constraints of the physics of the system that we capture in the models. They also tell us something about the functional form, whether it's x squared or the square root of x or some other thing, depends on the variable. But the point is that the observations in the real world are the thing that's doing the informing of the model. So that's really what observational programs do, is support our coherent understanding. When you've got a million lines of code, which is what you've got in a modern climate model or Earth system model, there's a huge number of potentially free variables, and it's only through observational programs that we kind of build any constraints into those models about how those variables interact. The Earth system modelling and prediction, we're installing a model, we're intending to run it, we're intending to use it to conduct experiments, and it'll be accompanied by a small suite of other modelling tools which help us meet those decision requirements. So it's not one tool and then trying to say, we know that this decision community needs something quite different, but we're going to use this anyway. The plan is to have a range of modelling and predictive tools which help us meet the needs of New Zealanders. So the output from Earth system models is used as a primary research product by the world's climate researchers. The way we've done things in the past is to have coupled model intercomparison projects, so we call it CMIP, where all the different model groups in the world get together, run some standard experiments. There's a long list of potential standard experiments they can run. They run the ones that they can because everyone has different resources, different supercomputers running at different speeds and so on. And they use that shared experimental setup as a way of comparing how the models are doing things and trying to capture the uncertainty in the way we model processes. And so, by and large, the climate research community globally uses that archive of model results as the primary way of bounding our understanding from models of how global climate processes and even processes on fairly regional scales work, large-scale processes. Well, we think of the Deep South National Science Challenge as and its relationship to the public as kind of a two-way thing. We have some expert knowledge of the climate system. The model is the best way of integrating the diverse influences on New Zealand's climate, but we also need to elicit from people their priorities about the sorts of things we should be studying. So I guess we can sort of draw a little loop. If there's if there's the public here, and there's the models etc, including process and observations here. We want to be responsive to the concerns that people have. We want to be addressing the things that they care about in the climate system, and then we want to make people understand what models do, what they can do, what they can't do, what their capabilities and limits are, the sorts of information that might come out, so that they can plan better for a change in climate. And the Impacts and Implications program is really about trying to connect with New Zealanders and trying to help them make better decisions, more informed decisions about the change in climate. We have 4 priority impacts areas for the Deep South where we think we should be leading, and there'll be other secondary climate impacts, indirect climate impacts, where other national science challenges or other research providers may well be better placed to lead. So the 4 that we think probably are our primary responsibility are droughts, floods, as in extreme weather events, shifts in the distributional properties of climate that matter for people's decisions. So, questions about frost thresholds and things like that, which matter for horticulture. And the last one is sea level rise, where we're interested in the long run in developing some more scientific understanding of sea level rise, but also the public policy dimensions of sea level rise, because it promises to be one of the most contested areas of climate change. So the idea there is that there'll be opportunities for New Zealanders to engage right across the processes and observations, the Earth system modelling and prediction, and the impacts and implications work. And we also want to improve, we want to do work in the area of using vision Mataranga. So we want to have improved Maori capability in those areas, have Maori researchers flourishing as Maori in those 3 other programs: process and observations, Earth system modelling and prediction, impacts and implications, as well as addressing the needs of the Maori communities up and down the country to plan for climate change. So I think it's kind of quite a distinctive challenge. I think I like its scope. It's large, it is ambitious, but I think partly because we're small, we can effectively fit most of the relevant people for climate change, for these parts of climate change, in a room, in a fairly large room, but we can do that, and most countries can't. So I think actually our scale, in a sense, gives us the opportunity to create something quite ambitious. It also gives us the opportunity to create a shared understanding of this physical science meets vulnerability, adaptation, and impacts needs. We think that this challenge can also do some really good research. The process and observations work will be published in international journals. The modelling outputs, we hope to evolve the model to a point where we can submit it to the large intercomparison projects that go on, where there are about 30 models globally. The question is always, why another model? It's a good question. They're expensive. And the answer is because the southern half of the southern hemisphere is usually not a priority for most people's climate needs. So the North Atlantic is probably the most studied body of water in the world, because a lot of rich people paying taxes pay for climate modellers either side of it. And so that tends to be the priority. For a long time, the southern hemisphere has been subject to quite large biases. I think the folks in the north are beginning to get to the point where they think those biases are important enough for their climates that they're beginning to consider them. But they'll never have the skin in the game for understanding this part of the world that we do. The social and policy sciences will also, I think we have some interesting things to say there if we focus our fire and, work on the right sort of problems. New Zealand's good at that stuff.